All right, guys, this is your Unit 12 review, open-ended. Let's take a look at problems 12 and 13. Now, are you going to get problems like this on the final, these multi-step thermochemistry equations? Yes, you are. But, all right, I am going to help you structure the question. This might be a your year only thing. Next year, I might have to change this video because I don't think I'm going to be doing it that way. But for this year, um, I am going to help you structure these questions. All right, so let's take a look at question number 12. How many joules are needed to heat 5 grams of ice at -5 Celsius into water at 90 degrees Celsius? So I've re-entered it here. Now, on your final exam, you're going to be getting a bit more information than that. In fact, you are going to have this question broken up into parts, not this exact question, obviously, but there will be a multi-step question on there. And I'm going to break it up into parts. All right. So how many joules are needed to heat 5 grams of ice at -5 Celsius into water at 90 degrees Celsius? Well, the first thing I'm going to say is find the energy needed to warm the ice from -5 C to, hey, if you guys maybe remember, the temperature at which ice melts, stops being ice, is 0 Celsius. So I'm going to have you find the energy needed to warm the ice from -5 Celsius to 0 Celsius. Then I need you to find the energy needed to melt the ice and turn it into water. Lastly, you need to find the energy needed to heat, warm the water from, well, when it's done melting, it's going to be 0 Celsius and it's going to 90 degrees Celsius. So, and lastly, add all the energies together to get the total. So, this kind of problem right here is going to be broken down for you into steps to help you structure it, okay? See here. All right, so the first thing we need to do is we need to find the energy needed to warm ice from -5 Celsius to 0 Celsius. So because this is a temperature change problem, we are going to use Q equals M times C times delta T. Now, fortunately for all these problems, Q is what we're solving for, so that simplifies things. We got 5 grams of ice, all right? The specific heat of ice, you will have to go to your final exam equation sheet, and here it is. The specific heat of ice is 2.03 joules. All right, so 2.03 joules per gram degree Celsius. And the change in temperature from -5 to 0, that's an increase of 5. So what energy in total is that? 5 times 2.03 times 5. The answer is, whoopsie, about 50.75 joules. Okay, so that is the first energy. That's the energy that it just took to warm the ice up to its melting temperature. That's not melting the ice, that's getting it to the temperature where it will melt. Okay, next, you need to melt the ice. So for that, you're going to use the Q equals M times the heat of fusion. All right. Now, once again, you're solving for Q. All right. So no algebra needed here. The mass of this ice is still 5 grams. All right. It was 5 grams of ice then. It's still 5 grams of ice. All right. And the heat of fusion, the energy it takes to melt ice, well, heat of fusion for H2O is 333.3. All right. And so we just multiply those together. 5 times 333.3. And we get that it takes 1,666.5 joules. That looks like a 5. Let me fix that. Joules. All right. to melt the ice. Now the second to last step is we need to know how much energy it takes to warm the water from 0 degrees to 90. Now that's another temperature change. Q equals M times C times delta T. We're looking for the energy. All right, the mass of this substance is still 5. 5 grams of ice, surprise, melts into 5 grams of water, right? The specific heat of water is 4.184. And the change in temperature from 0 to 90 is 90 degrees Celsius. So 5 times 4.184 times 90, and I get 1,882.8 joules. Now, you need to then take the energy from these separate steps and add them all together. So 50.75 plus 1,666.5 plus 1,882.8, and we get, oh, okay. Is this right? No. Oh, okay. The answer is almost exactly 36,000 joules. There we go. So that's the answer. So this is clearly going to be a big ticket problem on the final exam because it has multiple steps. So it's going to be worth as much as several smaller problems put together. So just make sure you're ready for this. Again, you're not going to just be handed this question on the final. It's going to be broken up into the individual steps, and you just have to follow the steps, okay? Now, this question number 13, I don't want to do. All right, and I'll tell you why I don't want to do it. One, because you're not going to be getting a 5-step problem on the final exam. And second, because it is a 5-step problem, okay? So if we were to look at this and just identify the steps ourselves, it's not hard. It just takes some time, all right? So 12.5 grams of ice at negative 18 Celsius turned into steam at 127 Celsius. So you would need to figure out the energy it takes to warm the ice from negative 18 to 0, right? Then you got to figure out the energy it takes to melt the ice. Then you got to figure out how much energy it takes to warm the water from 0 to 100. Then you got to boil the water. All right, then you got to warm the steam from 100 to 127. So like, yeah, it's not that hard. It's just a lot of steps, all right? It's a Q equals MC delta T, followed by a Q equals M delta H, followed by a Q equals MC delta T, then a Q equals M delta H, and then a Q equals MC delta T, all right? For your sake, in every case, the mass is the same, all right? But the specific heats are different depending on, what you're dealing with. Oh, ice has its own specific heat, all right? Water has its own specific heat, all right? Steam has its own specific heat. And there's different heat energies required to melt ice and to boil water. So you just have to find the values on here. But again, you're not going to have to solve a 5-stepper. The most I will give you on the final is 3 steps, like number 12. Okay. So I'm not going to go through all this. Yeah. Anyways, that's it. Goodbye.